I work at the Finnish Meteorological Institute, which is the National Weather Service and a public authority. But I'm actually a space center guy from the Arctic Space Center, still based in Helsinki. But so I combine all kinds of space information to many different services. That's what I do or have done for a long time already. And what is important in Finland, so I think Finland is we call the forests our green gold. So we, of course, are in a country that is since all times, or 1865, for example, is the year from which on the government owning quite a lot of forests as well. They have been tracking all the wildfires that they have had in their areas, usually forest fires. So that's the main interest. How much money did we lose? But this has translated to a clear path of, you can say, over, this very long period that, for example, the area that is burned on average has been going down for many decades and still is in a position to go even further down, even if we also, from a weather point of view, have more challenging conditions coming up. But the point for us at the Finnish Meteorological Institute is really that we have a law, which is a part of the Rescue Act, so which tells how firefighters and others what are their obligations and their rights. But there's a special, let's say, point for forest and grass fire warnings, which actually directly also impede on what people are allowed to do in the forests, so or in wildland in general. So this means that when we, as the Finnish Meteorological Institute, give a forest or grass fire warning, it immediately means that in that area, you are not allowed to make something which is called open fire. So open fires means campfires, disposable grills, or anything which is open, doesn't have a chimney in a way. That those kind of fires are then not allowed. And if you still make that, you are actually doing a criminal act. You can be prosecuted, and in the worst case, if a lot of forest is burned, you can be called to be responsible for it. I don't know about cases where this would have cost the person directly, but in principle, this is how strongly, in a way, the forest is protected, and the owners of forests in a way as well. Anyway, open fires also need a permit anyway from the landowners, and rescue authorities have extra also outside of the fire warning situation that we from the Finnish Met Institute say. They might also say for a certain area that open fires are not allowed. So this has translated for us at the Finnish Met Institute that we, of course, have to produce these warnings. The level of how we speak them out are these kind of certain regions, which are, can't know what the good English term for those are, but this is a certain kind of regional disintegration of Finland, which is for the, let's say, southern half. These are pretty big areas, but in Lapland, it's even every commune for themselves. So every, let's say, every little town or their area, which is pretty big actually in Lapland, they are themselves a unit. So we have to tell for each of them if there's a fire warning or not. And this really means something. Because we are doing so many other warnings, you see actually in this slide the warnings for today, which of course doesn't have any forest fire warnings because we have actually a lot of snow. This is, let's say, a little snowstorm almost that has been just going past us. So you need to see the warnings for the sea areas and for the road traffic. And in all of these, we have 3 different levels of warning. So just a kind of like normal warning, a higher warning, and then an extreme warning. That's why yellow, orange, or red. But the point is really that for a forest fire warning, even the yellow one already means that the law is in action and open fire is not allowed. So how do we produce this warning? To be able to produce this warning already in the, I think, late 90s, this Finnish fire weather model was developed. It is mostly about the soil moisture kind of index, but it is about not just it's the humus amount and that the moisture of that, because the whole point in Finland where we get let's say fires from are these clear-cut areas. So usually we don't have any problems with a normal forest catching fire, but it's always that when somewhere a cutting was done, so some forestry activity, that area is having a lot of dry or kind of small bits and pieces and rests of the cutting are spread around, and then the sun shines more easily on them, so it dries them faster. So this kind of area we try to model in our system. So it's half open treeless terrain, as we call it. That's how clear cuttings are defined, because that's the trees are away, but there are still some other let's say vegetation around usually. And for those we make let's say either the top 3 centimeters or the top 6 centimeters. So not too much of the ground layer is the one that this surface moisture is being kind of calculated for, and that's being used then for our indexes. And we do 2 different fire warnings. So one is for grass fire, but that's just really in April and May. We have this situation that sometimes when the snow melts away, we have, of course, grass underneath, which is not yet kind of like in a kind of phenologically active state, but it might be even brown or kind of dead grass. And when that dries fast, that's actually also something easy to catch fire. So for those, we have the grass fire index for that thinner layer, but then the most important part is this thicker layer, 6 centimeters. And for those, we really make the forest fire hazard calculations. And we are using for this both weather stations, but in essence for this picture that you see here on the slide, which is actually done at 1 kilometer times 1 kilometer grid all over Finland, we use all the weather stations and the weather radars to give things like air humidity, wind speed, air temperature, solar radiation, precipitation. So those combined, we then have this index calculated. For the next 10 days, which is our forecast time for the deterministic forecast, we also have a 10 times 10 kilometer grid where we have 10 days ahead about forecasts. And solar radiation is the one where we are not so well encompassing all of the country. So here we do something more kind of like 20 automatic stations have solar radiation measurements. So those fit that area, but then we are using also 50 stations that have an automatic cloud observation system that estimates for us then the solar radiation, so that we have a better cut for the solar radiation for the whole country as well. But in essence, that builds up our forest fire weather index. In Finland, you could compare it quite nicely to the Canadian fire weather index system, that there's this fine fuel moisture code. So there's a little bit of difference that we, in a way, think about the soil and the humus in it. And this fine fuel moisture code, in a way, tries to also think about all that stuff on top of the soil. But in general, they are very similar and pretty close to each other when you compare them, calculating both. But so these are the system where we get the index is numbered something between 0 and, well, again, has open-ended, but the numbers, if they are really high, they just go over 6, not much more. And so the extreme is for us 6 or more, 5 or more is the index that it's high, and 4 or more means that we are giving a warning now. On the map here, you would see that there are just very small warning areas here on the west coast. So there we would then look at, does it, let's say, have I think at least 1/3 of the area of this kind of thing has to be covered by the lowest level. If it's more extreme warnings, then even a smaller area can give the whole area a warning. But the color is then the average of this. Yeah, but then let's go forward to what we will have next summer as an operational service. So based on going through old cases and just looking at the situation that in Finland, we don't have really a huge problem with these forest fires. But of course, when Sweden, for example, has had sometimes these non-controllable fires as well, Finland did not send their fire crews to the Swedish side because we had to look at, 2018. Yeah, very simple reason. Our weather conditions were exactly as bad as yours. So in that sense, we kind of like thought, hey, we can't go over because we have to make sure that if now we get a fire with us, we are not in the same trouble as you. So that's why I guess 2 months later we came to help you. But for that immediate thing, we still had to just stick around. But this means that in Finland, we also want to now improve still this system and looking at both the Farsight system and Prometheus, so the American or the Canadian growth model systems. The Prometheus showed to be a little better. So that's what we have picked of what to implement. And we are really on the verge to get operational for Finland next summer. So if you look at this Prometheus growth model, then there really is the fire weather index system, which is, I should have had maybe a slide of that. But in essence, in addition to this fine fuel moisture code, there's also a DUF moisture code. So in a way, different ground most moisture things to say how easy would it be maybe to ignite something. Then there are 2 codes for the initial spread index, which means how if it flames up, does it kind of explode immediately or does it go slower? And then this, what was the name of it? Well, one other code, which is showing how fast does a fire progress. And then one factor which is used in, so the fire weather index in total is a combination of these other indexes. The one is the drought code. And there you need also, I think it was 30 days or at least a certain history of weather in this spot to combine that into the how dry might the whole thing be. So these are important, but then Prometheus is on top of that, using exactly all of those different indexes in the fire weather index system to then calculate forward. And for this, it needs at least to know information about the fuel grid, which means exactly that you have a grid or a kind of like raster information about the fire area, where for each raster you have, I think the original thing is that you have 16 different types of fuel that are present in Canada. They are not perfect for other countries necessarily, but for those you need to know that what is present in which grid point. And then the fuel lookup table will actually translate each of those fuel types into those parameters that make how fast does something spread or how easy does it something ignite. And then you need, of course, weather information, which in our case will be hourly information about temperature, relative humidity, precipitation, wind velocity, and direction. For the operational system, in principle, the weather information is the one that would drive how fine-grained you can go in time. So if you would have 10 minutes interval information, which we in a way we actually can make 10 seconds or I guess even a second. Every second we could take weather information from our observation network. So if you want, you could drive this model, of course, in a very short time span. But in general, this is, I think 1 hour is the normal type that you would do, but you could go, for example, also 10 minutes a piece. And you need, of course, then the starting point. So where's the ignition? You either have a single point, so one grid point, and the grid definition, of course, comes from how fine-grained is the fuel grid. That's how fine-grained you calculate these informations. Or you might have then a shape, so to show that this is the area that is burning, and then that is being looked at, or the perimeters of this fire. So these 4 things you have to have, but this Prometheus model is nowadays at the level 6 or version 6.3.4 or something, like at least way past 6, going towards 7. So it has developed a lot in the sense that it can put in much more fine-grained information nowadays. The one thing that it was initially just for flat surfaces, now with a digital elevation model information, it also understands, for example, the slope effects. So you need a digital elevation model then to put into for that. It will then calculate itself the slope and aspect figures from it. You can also put them in, I guess, directly. There are several physical features that you nowadays can put in. So you can put things that can't burn. So if you have a water body or you have something, then these obstacles can be defined, which I think is an interesting feature, because in a propagation model kind of real use situation, it might be interesting to say that, hey, this is our plan. So we will stop the fire here, we will stop the fire there. Where does it end then? So I think kind of not have to firefight just at whatever is happening just now, but being able to kind of see that, hey, with this tactics, we are differently in a position that it stops, might be interesting. And that is possible with those physical features to be put into there. But then there was already the discussion that if the wind grid is much more detailed, so taking in the, for example, the digital elevation model will give you a different type of wind field. So something called Wind Ninja is an extra software that can be used to make this very high resolution wind fields from the more coarse information that we have from the weather models, that they can downscale that to a more precise wind grid, taking into account, for example, how much drag is there in the because the wind will just up in the free atmosphere, it's fast, and then the ground will kind of slow it down, and that depends on what is there on the ground. So trees are different from rocks, and all of that will kind of depend on that, can be taken into account with these better wind grids. But especially information about fuel can be much more kind of high grained in detail of the specifics put up there. So you can put in nowadays that at what seasonal growth state are you with the kind of vegetation that you have there. So is it already greened up, or is it just developing, or is it already dying away and a lot of kind of like dead leaves on the trees? Those kind of things can be put in there. And then the information of those, let's say, grid fuel types that Prometheus can read nowadays, really you can define per percent how much conifer, how much broadleaf, the tree heights, the canopy base heights, all of that information can be put in to make it more precise. So here's just an example. Yeah, these are all the different files that you can put as an input. But in essence, I explained most of them. Yeah, so let's not stick around on that too much. So the propagation calculation itself is pretty much that you have the perimeter of these, so the shape of the fire. And then it will look at, based on those fire weather index informations that it has, for each grid point, it will look around this path for the most kind of like, I guess, the best kind of like propagation points in a certain distance. So that those points, it will kind of calculate where would that go towards and how fast, and then make these kind of small, you see it best in this picture, ABC, and it will then make small perimeters for those, and then connect then the outer rims of this fire again in C. And this it will do as many times until fire either is burned out, so there's actually no perimeter anymore that burns, or then that the simulation time has ended, so that we don't let it necessarily just calculate until forever. So if the whole world is burned, it would stop, but we will usually have some kind of kind of also limits for the grid, of course. We will not. So if it gets to the ends of the grid, it would also stop. But usually it just is like next 24 hours or something like that is put in, that we don't calculate much more. But it could be 3 days, for example, for a bigger fire, just to make sure that you see it. And then what you get from here is these perimeter vector files every time step. So if you have chosen the default 1 hour, then you have every hour ahead, you would have a forecast of where the fire lines are. You will have this kind of scenario report, but that's more about how did it run. It's really not so useful maybe for the firefighting. But we will then also have all those parameters, of course, that it was using in there. So if someone wants to see what is in a certain time step on those boundaries, for example, those build-up index, that's the name of the one that I forgot, then you can see where is the kind of most active fire part and where is the less active fire parts around this fire. Yeah, flame length. Okay, here it says. And front, flank, back rates of spread are separated. So there's probably also nowadays quite a good, this kind of directly useful information thought about in this production system then, that's, yeah, fuel consumption and stuff like that. Yeah, but I think when we have tested this system or to decide what to do, I think it was very clear that one of those key things that are not necessarily automatically there was this fuel grid information. That so Kolstela in 2019 finished his study on this, where he went actually through. I have a picture of one of those examples that he used Prometheus, Farsight, and I guess from the Canadian system there are 2 other kind of model versions of this growth model and Prometheus. So all of those were tested. How well do they work? And then also testing of what type of material is put into there. And one of the fuel map actions, and I have a little bit of mistake here. So the Corin land cover information is given in 20-meter resolutions. But in general, as this Corin land cover is done in a vector way, that vector resolution where the vectors are done is at 100 meters. So some fields you have higher, but in essence, what is more important than this resolution is actually the point that really was not good at all for those runs, that it spread much too fast. And the biggest reason is maybe not that the resolution was too coarse in the grid point idea, but it was too coarse in a way of differentiating different classes. So you can see here that, this is from the Finnish paper. So Mänty means pine. So the light green was just one pine. But if you look then on the lower picture, where there was the kind of longer standing pine and fresh pine, so the a little bit darker green was this pine that is already has grown higher. So where the crown is much more higher, the fire actually did not even kind of go to that area at all. So it stopped before that. It only just got those areas, and it got those areas much slower, where there was, for example, a grass cover, and also was slower on areas that had these higher pines, because it mostly was just kind of spreading on the floor or the ground. So I think this was a very important case of showing that, okay, if we don't have this kind of fine-grained fuel information, then the propagation modeling will not help. Like, it will just not give information that is useful. And that's why in Finland, this is what we go for. And in Finland, we are pretty fortunate that on a kind of like, we do have the LiDAR information. We have a very fine-grained kind of, not fuel type, but the vegetation of forests is very well kind of defined in our national kind of forest inventory informations. So we can do this high-grained map for ourselves. But in general, the time is now very ripe for these fuel maps to be also all over the world much more better, because nowadays Earth observation satellite data, we have a 10-meter resolution or Landsat at 15, 30 meters that can produce this all over. We also have a lot of more airborne LiDAR mapping, which is usually at something better even than 10-meter resolutions. Those are not always available for free. And of course, they are many times just made, for example, the Finnish LiDAR mapping, which has pretty much like 90% of the country nowadays covered. The problem there is that it started already, I think, 2010 or 11. And every year they have done a certain percentage of the country. So it will not be like the most recent information for all of Finland. For some, it might be last year's information. For some, it's already 10 years old. Okay, forest will change, vegetation will change in pretty long kind of like it's time steps, but it's still in 10 years, you probably have already something different. And at least in Finland, that LiDAR thing is therefore not necessarily the best system. But anyway, and all over Europe, if you look at it, then there are places where LiDAR data is available for free for anyone to use. In some places, you have to be a public authority to get it. And then the resolutions and many of those kind of like gritty details of how did they do it sometimes are making it difficult then to do exactly the same analysis all over. But in essence, we are in an era where it can be done. And here I took actually what the EFIS global fuel map has been, how that was done. That's the right side of the picture. And that used pretty much ready-made, let's say, Earth observation-based products and produced the global fuel bed maps from, these are based on MODIS data at 250 meters. And they used these biomes maps, land cover maps to combine it, but to be able to distinguish those fuel beds in the more types classes, which I said, but one of the most important factors in Finland was that if we have a very coarse, like only whatever, like pines or how are they others called? Damn, I just know the Finnish names. But different types of coniferous trees, for example, are very different for a fire. So if they all are just put into the same class, that does not work. So you need to be more high-grained in knowing exactly at what stage of growth is something and then what type is it. And you only get to that if you have a quite high resolution kind of mapping unit. So 10 meters, for example, is good. But within the 10 meters, you will not have super many different things. And for example, having two types of trees, usually you are fine with all 10-meter spots in Europe. So we are now at the verge where this can be done. And we are also on the verge of doing this kind of big data analysis systems where we need, of course, machine learning models to be able to do it. But as already those that EFIS was run in 2016, this fuel map was done. Already those maps, in a way, are based on machine learning methods. So the random forest kind of methodology is a machine learning methodology, for example, which is behind many of those. Or then they were using it's called genealogy, or like to model like genes are done. That kind of system is many times behind those canopy cover or canopy height maps. So all of those have been done like this, but we can also just put it all together and produce with a machine learning model from the original Earth observation inputs, these kind of fuel maps. And you also don't have to do, like the EFIS map already done, there's a lot of different stuff from the European Union Earth Observation Program, Copernicus, that many of those kind of informations that you would need to produce a map are already available. So for example, tree cover density at 10 meters, imperviousness density. So that means, for example, that areas that would not burn or are that infrastructure that you want not to burn, that all those informations are available at even density levels in one grid point. So pretty fine-grained. Dominant leaf types is available. So there's maybe not the kind of type, let's say granularity is not good enough, but still this helps you already also to at least validate and check if a machine learning model has done good. Grassland density you have there. Then there's a very nice data set for this, how to train these models. That Lucas, which is a land use and cover, a survey that was done with people on the ground. So people going to certain spots every 2 kilometers. There's these kind of, so the grid of 2 times 2 kilometers all over Europe. In all of those corner points, people have, or those will be defined what the land cover and land use is. They actually also not visit all of the spots, but I think it's 200 and something thousands every 3 years, and they will shift those points are visited. A lot of them are also photographed. And then what is important, that's where they define the land cover, the land use. So in land use, for example, you will know what crop type they were was planted there. In land cover, you will also have quite a lot of different classes. I think it's 80 classes or something of differentiating in this Lucas thing. So can use this for teaching this machine learning system. And then, of course, you need what should it learn from? So that's Sentinel-1 and 2 satellites. So a radar satellite that doesn't care for the clouds is the Sentinel-1. And then the optical Earth observation data from Sentinel-2. Those are available every 5 to 6 days at least. Over Europe, even more often, because we do have 2 satellites of each. So in that sense, there's really a lot of information available to train, for example, for 1 year that you would compare Lucas. You would not just look at that one time step or time in the year that they went to look at this place, but you could look at the whole growth season of the vegetation to understand that, this is a certain type of tree because now it was in blossom of some, for example, cherry trees. This small window that they are actually white or red or pink, you might actually see in pictures compared to then after that they turned green. So you can say cherry trees compared to whatever other trees. In that sense, you have a very good way of being precise and correct. But here, maybe I then leave the next step even in here, because this vegetation state is, of course, one factor more, again, to take in account when you have a good propagation modeling. And you saw already that in Prometheus, you can also fit in some of these things into the model. But when you know at what kind of how well does especially these leaf trees, so not the coniferous ones, that are they now green or are they already turning in autumn to yellow or red? That tells you, of course, a different situation for a forest fire. And here I just took from September 16th of this year. An enhanced vegetation index is a good kind of like comparison, for example, to what would be the live fuel moisture of these plants. So if they are darker green or if they are lighter green, then there's the difference of how good are they at the moment. You do have the problem with clouds. That's why I left them in. So there are 2 pictures on top of each other that you better see, that where we have white clouds, that they, of course, mix up the picture. So you can't always look at everything. And as you can see that on the 16th, not all of Europe was kind of covered. So you really need those 5 days, for example, to combine to have a full picture of Europe. But if you get even like 3 times a month for March to October, you do get the idea of where are you. And if you make a kind of like clever forecasting, you could even just kind of go through each vegetation type and see that a prognostic view forward and not needing to necessarily look at just one picture. And you could also fill in the gaps that the clouds were on top of you. So there's a lot of this kind of smart kind of information tech that you can use to make this. But I think this would really improve then even one step further, that the propagation models can be kind of super useful and precise. But that's what I had. So thank you for your attention. And if you have questions, you can ask them now or later. What you see there is a map of our Sodankylä station. So do you see my pointer? This is where, yeah. So this is the area. So here's the airport of Sodankylä. So Sodankylä is, wow, I guess 20,000 people only. But I think wildland urban interfaces are just a good example of, you see that all of these areas here are pretty much like forested or swamp or other wetland types. And okay, what rivers are protecting some, but some are directly connected to these. So this is the one site that we would, for example, we have here extensive amounts of instrumentation, both here on the swamp areas, in nearby forests. Well, I can't remember exactly the points, but also in other places in Lapland, so that we can really do this comparison of what the fuel map is to what we then measure with many means. Yeah, but that was me. Thank you.